Okay, 7-3 is proving triangles similar. So we're going to talk about 3 postulates and theorems that we can use to prove that triangles are similar. So just like we did with finding congruent triangles, we have several shortcuts that determine if the triangles are similar. So postulate 7-1 is the angle-angle similarity postulate. We abbreviate it with 2 A's and the similarity symbol so that we can distinguish it from when we were using congruent triangles. Now we're talking about similar triangles. So this postulate says if 2 angles of one triangle are congruent to 2 angles of another triangle, then we have triangles that are similar. So in these 2 triangles here, HJK and WYV, we know that angle H is congruent to angle W. That's why they have corresponding positions in our similarity statement. And we know that angle K is congruent to angle V. So we know 2 angles of these 2 triangles are congruent, so they must be similar. That's what this postulate says. The next theorem we have is the side angle side similarity theorem. So we're going to abbreviate that by side angle side, and in order to distinguish it from when we were using congruence, we need to put the similarity symbol after it. So this one says if an angle of one triangle is congruent to the angle of a second triangle, and the sides including those 2 angles are proportional, then the triangles are similar. So this picture is down here. We have 2 angles of 2 triangles that are congruent, and we know that these sides that are surrounding this angle are proportional. So I can compare 8 to 6 and 4 to 3. These are the same. They're proportional to each other. So since we have included angles and sides that are proportional, we know these 2 triangles are similar. Theorem 7-2 says is the side-side-side similarity theorem. Again, we're going to abbreviate that with an SSS with the similarity symbol at the end. This one says if the corresponding sides of 2 triangles are proportional, then the triangles are similar. So this is different from the side-side-side postulate that we used, side-side-side theorem that we used when finding congruent triangles. Now the sides need to be proportional rather than congruent. So this example is down here. We compare 8 to 12 because these are the corresponding parts of the triangle. So we have 8 to 12 and we simplify it. So our similarity ratio is going to be 2/3. Then we do the same with 10 and 15. Also reduces to 2/3. And then 12/18 also reduces to 2/3. All the corresponding sides are proportional, so we know these 2 triangles are similar based on the side-side-side similarity theorem.
Okay, now let's take a look at some of the examples. Are the triangles similar? If so, write a similarity statement and give the postulate or theorem you used. If not, explain. So in example A, we are given that angle O is 82 degrees, and we also have angle A as 82 degrees. So we have an example or an information about an angle, but we don't really have an information about side lengths. So if you go back to our postulate and theorems, I would suggest use the first one, angle-angle similarity postulate, because we can find that information about the angles, but we don't have any information about the side lengths, so these 2 theorems wouldn't be useful. Okay, so we have this angle, and if you guys take a look, we learned that vertical angles are congruent. And so now, looking at the diagram, we have 2 angles, 2 corresponding angles that are congruent. So by postulate 7-1, angle-angle similarities, we can conclude that the triangles are similar. So we would have triangle FAX be similar to triangle BOX, so that the angles are corresponding. So BOX. There you go. Okay, so that would be the answer for example A. So now I want you to pause and try example B on your own. And once you are done and ready to look at the answer, please press play. Okay, so in this example, we can actually use two different theorems. So I will show you both, and if you have one of them as your answer, then you are correct. So here you go. So in this diagram, we are given the side length of all three sides of the small triangle, triangle YAD and triangle YOJ, right? So that means that we can actually use side similarity theorem to see if all sides or all corresponding sides are proportional. So let's see. So in this side we have 4 over, for the big triangle, we can add the sides together or the segments together and say that OY is 12. So it would be 4 over 12 to compare two different corresponding parts, which would reduce to 1 over 3. Now we can have 3 over YJ, which would give us 9 total. So 3 over 9 also gives us 1/3. Now we need to check our final side, AD compared to OJ, which would be 5 over 15, and that's also 1/3. All three corresponding sides are proportional, so we can use side similarity theorem to conclude that triangle YAD is similar to triangle YOJ. So that's one answer. Some of you might have noticed that we actually have a shared angle right here for angle Y. So this angle YAD has this angle Y, and also triangle YOJ also has this side. So we already proved, or we already showed that the two sides that make up this angle are proportional right here. So we can also use side angle side to say that triangles are similar.
Okay, so for this one, it's a little bit difficult to see which parts are corresponding, so I'm going to go ahead and redraw the triangles so that it's a little bit easier to see. So I'm going to draw this one. I'm just going to rotate it a little bit so that it's up here. So I'm going to have P, E, and M here. I need to make sure I label what's given to me. So I have PE is 10, EM is 25. And then down here I'm going to draw this one, and I'm actually going to flip it so that it's in the same position, the same orientation. So I have A here, and then E is going to be right here, and T is going to be right here. So AE is 8, so I'm going to mark that, and ET is 20. Now I have these two triangles, and it's much easier to see which parts are corresponding because I've put them in the same orientation. They look similar now. So let's see if they are similar based on our postulates. So this here, I do want to make sure I mark in the picture. They are vertical angles in my original picture. So we know vertical angles are congruent, so I can go ahead and mark that in my picture here. So now I have an angle that is congruent. I don't know anything else about the other two angles, so I can't use angle-angle similarity. But I do know these sides here, so let me see if they're proportional. Okay, so I'm going to set up a ratio here, 10 over 8. And when I simplify that, I'm going to get 5 over 4. Then I'm going to compare these two sides, 25 and 20. And when I reduce that, I get 5 over 4. So I do have them having the same ratio of similarity. So these sides are proportional. So since I have two sides that are proportional and the included angle, I know that by the side angle side similarity theorem, triangles PEM and triangle AET are similar. So I have the similarity statement here. Okay, so in this next example, we need to determine, are these triangles below similar? We want to give a reason why or why not, and if they are, we'll need to find the value of x. Okay, so let's go ahead and look here. These symbols here are the arrows. They mean that these two lines are parallel. So I know a lot of things about the angles that are made by parallel lines cut by a transversal. So these two here I know are congruent because they're corresponding angles. They're in the same position here. And this is parallel lines cut by a transversal, so I know these are corresponding angles and they're congruent. The same thing over here, if I have parallel lines cut by a transversal, I know that these two angles here are also congruent because I know corresponding angles are congruent. Now I know that two angles of two triangles, this smaller triangle on the top and the whole larger triangle, I have two angles that are congruent. So I can use the angle-angle similarity postulate to say that these two triangles actually are similar. Since they are similar, then I can use proportions to find this missing side. So I'm going to go ahead and this side here, 6, is the corresponding side to this whole side here. The length of this whole side is 8. So, because I'm going to add the segments 6 and 2. So I get 8. So 6 over 8. And then this side of this triangle is corresponding with this side here, x. So I'm going to have this, set up this proportion, so I have 9 over x. Then I'm going to cross multiply. I'm going to get 6x is equal to 72. When I divide by 6, I'm going to get that x is equal to 12. So this length here is 12. We could only use this proportion because we had already proven that the triangles were similar by the angle-angle similarity postulate. Please pause the video now and try the next example on your own.
Okay, let's read the problem together. It says, to estimate the height of a pole, Johnny stood so that his shadow and the shadow of the pole coincided. Johnny is exactly 2 meters tall. He was standing 6 meters from the pole and his shadow measured 3 meters. How tall was the pole? Okay, so Johnny here, he probably doesn't have any rulers or measuring tapes, so he is using similar triangles to figure out the height of the pole. So let's look at a given information. It says Johnny is exactly 2 meters tall. So head to toe, we'll write 2 meters here. So in general, whenever you have a word problem, I highly suggest you drawing the diagram and record all the information that's given to us. Okay? So here you go. He is standing 6 meters from the pole, which means from here to here, the distance is 6 meters. And his shadow measured 3 meters. So where he's standing to the tip of the shadow, that was 3 meters. And we are looking for the height of the pole. Since we don't know it, we'll call it x. Okay, so before we start using proportion, we need to make sure that triangles are actually similar. Without knowing that the triangles are similar, we cannot use the proportions. So, let's see. We have this small triangle right here, triangle DHE, and a bigger triangle, triangle DGF, and they have a shared angle right here, angle D, so they have one corresponding angle right there. We can also conclude that the poles are usually perpendicular to the ground, so let's say that this is 90 degrees, and also people tend to stand perpendicular to the ground, so we can also say that this is 90 degrees. So just like the example before this problem, we have an angle, a corresponding angle, and another set of corresponding angles congruent. So we can conclude that the triangles are similar by the angle-angle similarity postulate. Okay, so I'm gonna write down triangle DHE is similar to triangle DGF. GF. Alright, now let's solve x using proportion. So we can say that side ED, which is 3, is corresponding to side FD, which would add up to 9 meters. So 3 over 9 is equal to 1/3. That means that we want our proportion of HE and GF to be also 1/3. So we can have 1 over 3 is equal to, smaller side, since 3 was in the numerator, we'll have 2 in the numerator over the larger side, x. Cross multiply, we have x is equal to 3 times 2, which is 6 meters. So that's the answer.
After this lesson, you should be able to prove triangles are similar using the angle-angle similarity postulate, the side-angle-side similarity theorem, and the side-side-side similarity theorem. You should also be able to, once you've used one of those 3 similarity postulates or theorems, you should be able to find missing links after you've proved the triangles are similar. So it's very important that you first prove the triangles are similar. If you feel like you still need some more practice or still need some more explanation, feel free to rewind the video and rewatch any part of it. If you feel ready, please go to the Google form and fill out the Google form with the practice questions and submit your answers. Thanks for watching.
Bye.